Okay, welcome back. Today we're going to talk about solving using identity. Um, First exercise is again I want we to solve exactly. Solve on exactly should be swap these two 0 to 2 pi. Okay, first I have 3 cosine theta at 3 equals to 2 sine square theta. Now, whenever we see the square, we need to think about the Pythagorean theorem, which is sine square plus cosine square equals to 1. So that means sine square equals to 1 minus cosine square theta. Now, let's rewrite this. I have 3 cosine theta plus 3 equals to 2 times 1 minus cosine square theta. So the good thing of doing this is we can, instead of dealing with two trigonometry functions, we're just dealing with one, which is just cosine. Now, distribute them inside. I got 2 minus 2 cosine square theta. And then you can either choose to rewrite it as x and y or just use cosine. I am just go ahead and use cosine because I feel like I'm more familiar with cosine now. Okay, I'm going to move all the elements to the left-hand side so that the right-hand side is equal to 0 so that I can either apply the AC method or quadratic function. So AC method is you want things to multiply equals to 2, and when they add, it's equal to 3. Well, this one is easy, is 2 and 1. So that means I have, this is square. 2 cosine square at 2 cosine theta at 1 cosine theta at 1 equals to 0. And factor the common factor with the first two group. And this is the second group. Okay, common factor is 2 cosine theta times cosine theta plus 1. The second group, I can just do cosine theta plus 1. Okay, now common factor, cosine theta at 1. Then I have cosine theta at 1 times 2 cosine theta at 1 equals to 0. Then I can solve cosine theta is equal to -1 or cosine theta equals to -1/2. All right, not bad, not bad. Now, it's easy for us. When does cosine theta equals to -1? Is when theta equals to pi. That one, we are done. We solve it. I'm going to circle my final answer. Or maybe use this one because I use the red pen a lot. Second one, when does cosine theta equals to -1/2? So the negative give us two information. One is this is going to be in the second and the third quadrant. Second, the 1/2 tells me that, okay, the reference angle, I don't have enough space, I'll just go ahead and use theta prime, meaning the reference angle, it will be 60 degrees or pi over 3. Okay, with these two information, now let's find the answer. Unit circle. In second and third quadrant, I have pi over 3. Let me use a different color of pen. So the first solution is pi over 3 for the reference angle in the second quadrant, which means it will be this guy. So this is pi minus pi over 3. which is 2 pi over 3. That would be our second solution. And the third solution would be in here with the reference angle pi over 3 in third quadrant. So the solution would be pi plus pi over 3, which is this whole thing. So it's 4 pi over 3. So that is my third answer. So totally, we got 3 answers for these questions. Now, I'm going to teach you another way to do this question is checking our answer with decimals. How do we do that? Now, let me open up the decimals. Type in our function. Our function is 3 cosine x plus 3 equal to 2 sine square x. Okay, this is a little bit off. Let me rewrite this maybe into the cosine after we transform the function. So after we transform it, we have 2 cosine square. Or maybe the problem is the square. Let me try this again. I have 3 cosine x plus 3 equals to 2 sine x and square. Nope, it won't work. Let me change it to the after the transform one, which is 2 cosine x square. Okay, so far so good. At 3 cosine x at 1. Okay, equals to 0. Okay. At 1, not at 2. Okay, and we want, remember that we just wanted the domain in between 0 to pi, so that means I want to restrict x from 0 to 2 pi. Oops. Let's see, do we have that? Oh, this is 0, not O. Okay, look, after we restrict them, let's check our answer. Our answer would be this one. Look, it's 2 pi over 3, and another answer would be 0, and another answer is 4 pi over 3. That's it. That's our solution. Okay, let me recap this. When you check your answer, one thing we need to be careful because we just experienced that it won't work if you put it cosine and sine at the same time. So the best way to do it is to put it in after you transform it under the same trigonometry function so that we can check our answer. How do we know which point is the answer? Because we want it to equals to 0. So that means when we look at the graph, we want to find when y equals to 0, where do they intercept? They intercept with these 3 points. So that means this 3 point, it will be our answer. 2 pi over 3, pi, and 4 pi over 3. So decimal or the graphing is very super powerful. It will help us to check our answer. Okay. Next question is second exercise is cosine 2x equals to 1/2. And remember that x is on 0 to 2 pi. So that means 2x will be on 0 to 4 pi. You times 2 on all of them. Okay, how do we do that? Well, we can let 2x equals to theta, and then x, you divide by 2 on both sides, will give you half theta. That makes sense, right? So now let me rewrite the question. So cosine 2x, we write it, it gives me cosine theta equals to 1/2 That's good, that's good, that's not hard. Cosine theta equals to 1/2 tells us two things. One is this is going to be in the first quadrant. Second, this is going to be, no, not just first quadrant, also the fourth quadrant. And second, 1/2 means the reference angle equals to pi over 3. Now, let's do this. We found that the first one is 60 degrees. That's the easy one. And second one, also 60 degrees. So that means, or pi over 3. So that means the two solution would be either pi over 3, and the second one would be 2 pi minus pi over 3, which is 5 pi over 3. Here's two solutions for theta, but remember that theta is what? It's 2x, not x. So we found out the answer is because in here we let 2x equal to theta, so that means 2x is equal to pi over 3. 2x also equals to 5 pi over 3. But not done. Not done. This is a little bit tricky because 2x is in the domain from 0 to 4 pi. So that means this angle is not enough. They're going to rotate this again. So that means we can add another 2 pi from the first answer. So it's equal to pi over 3 at 2 pi. They're still within the domain less than 4 pi. So that is 7 pi over 3, right? Is it 7? 6 over, yeah, it's 7. Similarly to the second one, we need to add another 2 pi so that I have 5 pi over 3 at 2 pi, which is, meaning that we'll repeat that again, is 11 pi over 3. So that gives us 2x. So check. 2x is this full answer. So we're trying to solve for x. So that means we need to divide it by 2. So that means x equals to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All of these are less than 2 pi. So that would be the solution. And also, we can check our solution on decimal. Let's check it on decimal, see if we got 4 solutions. Let's take a look. We can keep that yellow line. We got what? Cosine 2x. Okay, that's cosine 2x. And this is equals to 1/2. Let me move the purple one into 1/2. And the x is from 0 to what? 2 pi. Look, we do have 1, 2, 3, 4 solutions. And we are right. Always check your answer with decimal. It's super helpful. Okay, that's it for this section. I'll see you in the next video.